All right, so we have another vector decomposition problem. There's f, and I want to decompose it into components in e hat 1 and e hat 2 directions. And this problem is a little bit different because I'm not giving you the angle at which these basis vectors lie, but rather I'm saying that, let's say, the e hat 1 direction corresponds to this sort of angled line right there. And again, I'm not giving you an angle, I'm giving you a ratio of two sides of a triangle here instead. So I'm going to want to write this decomposition in terms of these lengths, A and B. So let's look over here, get rid of that, put this, oops. So when I construct a vector triangle, this is what I get. There's the vector f, that's the hypotenuse of the vector triangle, and I've got two other sides that are parallel to the e hat 2 and e hat 1 directions, respectively. So this vector f can be decomposed into a vector that goes this way along like so, and another vector that goes this way. These two vectors are arranged tail to tip, so f is the sum of these two things. And how am I going to decompose this vector? It's sort of there geometrically, but how am I going to write it symbolically? So for the moment, just briefly, I'm going to introduce this angle theta right here. Again, theta is something that I'm defining. It's not something that was given to me. But if I go along with it, then this angle theta right here corresponds to this angle theta right there because, well, it's the angle between the vertical and the e hat 1 direction, right? Which is exactly that. So let me write this vector decomposition in terms of that theta, and then I'll go a little bit further and write it in terms of A and B. So here we go. So the e hat 1 component's got a cosine theta in it because it's it's a side adjacent to that angle. And then the e hat 2 component, which is that way, that's got a sine theta in it, just because it's the side opposite of the angle theta. Checking the signs, this piece in the e hat 1 direction, that's in the minus e hat 1 direction, so I'll put a minus sign right there. This piece in the e hat 2 direction, that one right there, is in the positive e hat 2 direction, since those two directions coincide. And that would be my vector decomposition if I could write it in terms of theta, but I can't write it in terms of theta, right? I have to write it in terms of A and B because those are the quantities given to me. But you'll notice if I go back to this original triangle, notice that cosine theta, that's the length of here, the length of the hypotenuse divided by the adjacent side. Well, excuse me, I got it the other way around. Cosine theta is the adjacent side divided by the hypotenuse. The adjacent side has length A, the hypotenuse has length A squared plus B squared square root. Right? So cosine theta in terms of A and B would be this. And likewise sine theta, that would take into the opposite side, or B divided by the hypotenuse. Cool, so if I make that substitution, then I get a slightly different expression for my vector decomposition. And this is what I get. Again, I just made the substitution for the cosine and sine in here, and that's my final answer.